everyone. In this video, I want to go over an example that uses Snell's law in order to find this angle of incidence right here. So what's happening is that we have a ray of light is coming in this way on the left here. It's refracting through this glass lens, and then it's refracting again as it goes back into the surrounding, which is air. And based on the angles that we're given, we have to figure out the fourth angle. So the first thing is that, yes, it is air on the outside. So that means that the index of refraction is 1 on the outside. And we don't know the index of refraction of the glass, but that's okay, we can figure it out. So usually what we do when we have a problem like this is we have to define all of our angles with respect to the normal. That's what these dashed lines are. That's the normal to the surface. So that means that phi here is the angle of incidence, and theta 3 here is the angle of refraction. So we could set up Snell's law. Now we don't have enough information, but we can still set up Snell's law here because that's the incidence. So Snell's law says n1 sine theta 1 equals n2 sine theta 2. But the angles can be whatever we want to call them. So over here, for the incident angle, that's phi, and then the index for this one is 1. Since the other angles are labeled 1, 2, 3, let's just call phi, let's just call that theta 4. And that way, this index that goes with this angle, since this ray is in air, so this index goes with that angle, let's call it n4. So instead of writing Snell's law like this, we can say n4 sine of theta 4 is equal to, and then on the right side is the refracted information. So theta 3 here is the angle of the ray with respect to the normal. So the problem gave us the correct angles. And then what's the index that goes with the glass? We don't know. We can call it n3. So n3 sine of theta 3. So we definitely don't have enough information. We know n4 and we know theta 3, but we're looking for theta 4, but we don't know n3. So what we can do is we can take a break from this side here and look at the other interface and set up Snell's law over here as well. So over here, this ray is now the angle of incidence because it's hitting the surface here. So the index of refraction that goes with this angle is still the glass, but I like to keep the numbers the same, so we can call it n2, which is going to be the same as n3, but I'll just call it n2 so it goes with theta 2. The ray is in glass. We'll call the index of the glass n2. So we'll have n2 sine of theta 2 is equal to, and then the refracted ray is theta 1. Note that all of these angles are with respect to the normal. So it's going to be n1, we'll put the air that's out here with this ray, n1, which is air, n1 sine of theta 1. So for this interface over here on the right, we have 3 things that we know. We know theta 1, we know n1, and we know theta 2. So that will allow us to solve for n2, which is the index of the glass. So let's go ahead and do that. n2 equals n1 sine of theta 1 over sine of theta 2. You can plug in the numbers. 1 times sine of theta 1, which is 29, over sine of theta 2, which is 21. Let's go ahead and plug that in the calculator, and that's going to give us 1.3528, etc. So I'm still going to use an unrounded number for future calculations, but I'll just round it on the screen here. Now we can go back to the first interface, we just found N2, which was the index of refraction of the glass, which is the same as N3. So we know that this N2 here is the same as N3. So N3 is now 1.353. They're the same thing, they're both in the glass. So now we have N3, we can solve for the unknown theta 4, which is the original phi. So get sine of theta 4 equals N3 sine of theta 3 over N4. Then to get theta 4 by itself, we're going to have to take the inverse sine of both sides. That will give us theta 4 by itself. So we take inverse sine here, that gets rid of sine. Then we take inverse sine on the right hand side, take the inverse sine of everything, like this. And we can go ahead and plug in all the numbers. So theta 4 is equal to sine, inverse sine of 1.353 times sine of theta 3, which is the 25 degrees, over, within the parentheses here, over N4, which is 1, so that's okay. And then we plug all of this in our calculator, and that's going to give us 34.87, so we can round it to 34.9 degrees as theta 4, which is the phi that we were looking for.